Hello, class. Welcome back to lecture 12. Today we're talking about the zero product rule. So, very important rule having to do with the number zero, and it's what makes zero the best. Okay, so why is zero the best? It's because when you multiply two things together, so I'll just call those two things A and B, but they're going to stand for lots of different things later. When you multiply two things together and they happen to multiply to be zero, you can conclude, well, the only way that you could get zero by multiplying two things to be zero is if one or the other is zero. And this is actually very powerful and lets us solve lots of equations. So this is called the zero product rule. It's very different from other numbers. For example, this does not work for like 10. Like if you have A times B equals 10, that does not mean anything. It doesn't mean A equals 10 or B equals 10. So it's a very special number. Zero is a very special number because it's the only number that does this. And so that's what we're going to use a lot today. Okay, so it doesn't work for other numbers like 10. Okay, so let's see where this comes into play. So what it does, it lets us solve equations involving polynomials very easily. If they're already factored out. So for example, if I write x minus 2 times x plus 4 equals 0, I can solve this using the zero product rule. And it's because the zero product rule says I'm multiplying two things together. So this is sort of acting like A and B here. And multiplying two things together and they're equaling 0. But that just means that this is going to be 0 when either one is 0. So I just have to think about when is x minus 2 0? Or separately, when is x plus 4 0? So you see these are acting as my A or B being 0. But you don't have to write A and B every time. It's just the rule that if you multiply two things to be 0, then that can only possibly happen if either one is 0. And then we just solve these two equations individually. So this tells us x equals 2 if I just add 2 to both sides. And this tells us x equals -4 if I subtract 4 from both sides. So the zero product rule allows us to solve this equation for these two values of x. But it's even more powerful. We can solve more complicated things. In fact, works for more multiplications. So for example, if I had like x plus 1, x minus 2, x plus 7 equals 0, I would be able to say that each individual factor equals 0. And then I would have 3 values of x. So x equals -1, 2, and 7 if I solve each one of these. So this is the power of the zero product rule. But of course, what this means is I better know how to factor things because this is coming from a polynomial that's already been factored out. Same thing here. So luckily, we just learned about factoring, so we'll be able to use that. Okay, so now let's get down to the types of problems we're going to deal with. Things like this. Solve x squared minus 5x equals 14. So this is saying that you have some number, and if I square it and then I subtract it by 5 times itself, that'll get me 14. So it's incredibly hard to just think about like, oh, what could x possibly be to make this work? And so that's why we use what we have just learned. So what we need to do is get 0 on one side. Easiest way to do that would be to subtract 14 on both sides and end up with this. Now, this is an addition of 3 things. It's x squared minus 5x minus 14. We don't have a multiplication, so we can't use the zero property yet. So next we need to factor. That will allow us to use the zero property. But luckily we've practiced factoring so much that hopefully we can do this pretty quickly. So if you do the box method, you're going to get x minus 7 and x plus 2. And minus 7 plus 2 will multiply to be negative 14 and add to negative 5. So now we're back in the previous situation where we have two equations that we just solve both of them and get our two solutions. So notice that means that these two numbers obey the original equation that we started with. So it'd be hard to just look at this and think like, oh yeah, I know it'll work. 7. So that's not at all how it works. You have to do all this process and then you realize 7 will work. And so will negative 2. Okay, so that's pretty much how all the examples will go. Maybe get a little bit more complicated in various ways. So this one is already set up nicely. It already has 0 on one side, so I don't have to do that step. I just need to factor the left side. So here I can use my box method. So 2 times 2 is 4, and then negative 5 goes up here. So I need to multiply to be 4 and add to be negative 5. So these are going to be the ones that do it. Negative 4, negative 1. So then remember how this one works. I just replace the middle negative 5x with minus 4x and minus 1x. So it still equals 0 the whole time. So I have an equation that I'm solving. So I'm going to keep that 0 there the whole time as I work on the left side. And then I factor by grouping. So I take out 2x out of the first two, left with that. And then out of the second one, all I can do is really take out a negative 1. And I'll get the same thing. So remember, the goal is that these two should be the same because now I can factor them out. And so if I take x minus 2 out of 2x times x minus 2, I just have 2x left. And if I take x minus 2 out of negative 1 times x minus 2, I just have the negative 1 left. So now here's where the zero product rule comes in again. So this tells me x minus 2 has to be 0 for this to work, or 2x minus 1 has to be 0 for this to work. This one I just add 2. This one I have to add 1, and then I also have to divide by 2. And then I get 1/2. So those two numbers will obey the equation if I plug them in for x. Okay, so let's do a couple more. It's not going to get much crazier than that. Notice I'm only doing powers of 2 at the most because it's much harder to factor out higher powers. So we only know how to do these ones really. Okay, so same idea. If I want to solve something like this, I need to first get 0 on one side. So I got to subtract everything over to one side. So I'll subtract the 2x and the 7 to the left. And then I'll simplify a little bit. These will combine into negative 9x. And now I will factor using my box method. So negative 21 goes down here because of 3 times negative 7. Negative 9 goes up here. So let's see what adds up to negative 9 and multiplies to be negative 21. Let's see, 7 and 3 is 21. So if I do heck. Hold on, give me 1 second. Where did I wrote it down wrong? Aha, I did write it down wrong. Sorry about that. So this should have been initially a 2x here, negative 2x. So let's fix that. Otherwise, this would have been much too hard to do. So it should be a negative 4x now. So this should be a negative 4. Okay, so now I can do it. So -7 times 3 will multiply by -21. -7 plus 3 will be -4. So -7 and 3 are what I want. So then I rewrite this as 3x squared minus 7x plus 3x. Replacing the -4x like we learned last time. And then I'm going to factor by grouping. So here I'm going to take out an x because that's all that goes into the first two. And here nothing goes into it. So it looks a bit weird. But secretly there's always a 1 times anything. So I can think of it as there being a 1 times that 3x minus 7. So now it looks a little bit nicer. So when I factor out 3x minus 7, it's more clear what's left. So from the first term, there's just this x left when I take out the 3x minus 7. Oops, sorry. I took out an x, so that should not be squared anymore. Minor typo. Okay, and then from the second one, there's just this 1 left. And now I'm back into the zero product situation. So 3x minus 7 equals 0. X plus 1 equals 0 gives me my two solutions. 3x equals 7 by adding 7 to both sides. Dividing by 3 to both sides gets me the answer I'm looking for. And over here, you just got to subtract by 1. Okay, so sorry about that initial typo, no problem. Okay, so let's continue. This one's a bit of a trick question, but if you're paying attention at the very beginning, you'll be able to not be tricked. So here, it doesn't look like the previous ones. It looks like the left side is already factored. So you might think, oh, it's already ready to go. I'll just set each one equal to 0. But the problem is that the right side is not just 0. So the zero product rule means that the other side better be 0 or it's not going to work. So what I need to do actually is multiply it out. Then get to one side. Because although the left side is already factored, I need everything to be combined together before factoring, because this doesn't help me. The fact that they multiply to be 10 doesn't help at all. So I'm going to multiply them out. So I get x squared minus 3x plus 6x minus 18 equals 10. X squared plus 3x minus 18 equals 10. So now I'm going to get them all to one side at this point so that I can use the zero product rule. So I get this. Okay, and then now I can factor. So x minus, so 7 times 4 will be 3, negative 28. If I do positive 7, negative 4, and then 7 minus 4 will be 3. Okay, so now I'm back to my usual situation. So now I can do the zero product rule because there is a 0 on the right side. So my two answers are negative 7 and 4 by subtracting 7 and adding 4 on those two equations. Okay, so I just want to do a mild word problem. So but it's really the same kind of stuff. So something like this. Solve for the two consecutive positive integers that multiply to be 756. So this is sort of like a puzzle type question. It's not really a word problem. It's more of a puzzle. And the trick is understanding what does it mean for things to be two consecutive positive integers. So like examples of those are like 8 and 9 are consecutive positive integers. 10 and 11 are another. 15 and 16 are another. And so on like that. The problem is I need them to now multiply to be 756, and I don't want to just check everything. So these multiply to be 72. These multiply to be 110. I'm not just going to check every pair because it'll take way too long, but we can actually think a little bit harder and then figure out how to write this in a way that uses the stuff we just learned. So what does it really mean for two integers to be consecutive? Well, it really just means we can call the first one x, and then the next one will be x plus 1. So then we want what? We want x times x plus 1 to be that 756, because we want the number times the next one to be 756, the two consecutive positive integers to multiply to be 756. So x is the first and x plus 1 is the next one. So they got to multiply to be 756. Okay, so then what we really have to do is solve this. But we know how to do that now. We got to get everything to one side. So first I'm going to distribute that x through, and then I'm going to subtract the 756. And now I just need to know how to factor 756. So I'll save you the trouble, and it's going to be positive 28 minus 27. So then zero product rule, x plus 28 equals 0, x minus 27 equals 0. So we found our two solutions to this equation. But what's our actual answer to the question? Well, negative 28 is not positive, so this one does not answer the question. So instead, it's this one. This is the first one. So what is the pair going to be? So it's going to be 27 and 28. 28 would be x plus 1. All right, and then the last thing I want to mention, which we're not going to do much about, it might be on the worksheet as like the tough problem. But in the future, you'll see this a lot. We can also use this with functions. For example, if you want to solve for when f of x equals 0, this will come in handy quite a lot. And there's lots of reasons why you might want to solve for when a function is 0. So when a function is 0, that means that's when it's crossing the x-axis here and here, for example, if I just draw some random picture. So these x values are where the function equals 0. And there's a million reasons why you would want to know when a function equals 0, depending on how much more math you want to take and learn. But it's very often useful to figure this thing out. And so you can use the same techniques. So for example, if this is your function, x squared minus 5x plus 6, then you can solve f of x equals 0 by doing the same thing, by just setting the function part equal to 0 and factoring. So this would be minus 3 and x minus 2. So these are your two equations, and then you get x equals 3 and x equals 2. So now not only are we solving for x values, we're saying that I have this function, and even if I don't know how to graph it, I can say that at 3 and at 2 is when it touches the x-axis, or when f of x equals 0. Oops, that's not 3 and 2, that's 3 and 5. Okay. Let's fix that. 3 and 2. Okay, and I think that's all I want to say for today. So I will see you next time.